Mr. Right here, and welcome to my All of IGCSE Indices film. Now, this film contains all you need to know about indices, about powers for your Edexcel IGCSE, and indeed for every other GCSE board also. Clearly, I'm hoping you're going to enjoy the video. You're going to find it useful. If you do, please hit like, please leave me a comment and tell me how the video has been for you. Of course, if you've got any questions as you watch the film, leave me a comment and I will respond. So what are we covering in this film? Well, there are 5 sections. First of all, we'll look at positive integer indices and how to deal with those. Then fractional indices, negative indices, and then we'll look at fractional and negative indices algebraically before, in the last section, we work our way through some IGCSE questions. There are some useful links in the description, not least to all those IGCSE questions, so you can download them and work alongside me if you want to. And there are also some useful links to other bits and pieces on the channel which will help you if you're preparing for your exams. Right, enjoy the film. Let's get on with the maths. Section 1, positive integer indices. So in this section, we're talking about numerical expressions such as this one, 7 cubed, or algebraic expressions such as this one, x to the power of 4. Now, these are positive integer indices because the power, or the index number, is a positive integer. Right, now you probably already know that 7 cubed means 7 times 7 times 7. And similarly, x to the power of 4 is x times x times x times x. Now, there are 3 rules with positive integer indices that you need to be pretty fluent on. The first concerns when you have an expression like 7 cubed and you multiply it by, for example, 7 squared. Now, very briefly, because I imagine that you've covered this already in school, 7 cubed is 7 times 7 times 7, times 7 squared is 7 times 7. So that is the 7 squared, and 7 times 7 times 7 is the 7 cubed. So 7 squared times 7 cubed is 7 times 7 times 7 times 7 times 7, which is, of course, 7 to the power of 5. In the same way, if we look at an algebraic expression, let's look at x to the 4 multiplied by x squared. Well, x to the power 4 is x times x times x times x. And then I'm going to multiply that by x squared, which is x times x. So what have I got there? I've got x to the power of 6. So what's happening here, of course, is that the 2 powers here are being added to give me the power on my answer. That's because you could say to yourself, there are 4 x's all multiplied together for x to the 4, and then 2 more x's multiplied together for the x squared gives me 6 x's all multiplied together. So the first rule of positive integer indices is that x to the m multiplied by x to the n is the same as x to the power of m plus n. You add the powers when you are multiplying. Right, the second rule of positive integer indices. Well, it's the inverse of the first rule. So let's move over here. The second rule is about division. If you had 4 to the power of 5, and you were dividing that by 4 to the power of 1, just by 4, well, 4 to the power of 5 is 4 times 4 times 4 times 4 times 4. And now I'm going to divide that by 4. Well, if you're going to write out 4 to the power of 5, and then you're going to divide it by 4, you might wonder, why would I bother to write out this last multiplied by 4? Because I'm just going to divide by 4, which is the inverse of the timesing by 4, so that'll just disappear. So you might as well just write out that. So if you're going to divide by 4 to the power 1, actually, you're just going to have a 1 less 4 in this expression. So 4 to the power 5 divided by 4 to the power 1 is 4 to the power of 4. In the same way, algebraically, if I look at a to the power of 6 divided by a to the power of 4, well, in this case, I've got a times a times a times a times a times a. That's my a to the power of 6. But if I'm going to divide by a to the power of 4, then actually I could write divided by a, divided by a, divided by an a, divided by an a. Or I could just say, I won't write that one down because it's cancelled out by that. I won't write that one down because it's cancelled out by that. I won't write that one down because it's cancelled out by that. I won't write that one down because it's cancelled out by that. And lo and behold, you're just left with a times a, or a squared. So a to the 6 divided by a to the 4 is a squared. And a moment ago, we looked at 4 to the power of 5 divided by 4 to the power 1, which was 4 to the power of 4. So you can see that when I divide, I subtract the indices, which is the opposite of when you multiply, because when we multiplied, we added the indices. So to put that rule into algebraic terms, I suppose we could say that x to the power of m divided by x to the power of n is x to the power of m minus n. But if you're like me, you'll just remember that when you divide, you subtract the powers. Right, the third and final rule with indices is coming up. We've looked at multiplying, and we've looked at dividing. Now we're going to look at something that looks like this. Let's say, for instance, 2 cubed to the power of 4. Or algebraically, we could be looking at x to the power of 3 to the power of 5. Let's look at the first expression on the left, this numerical one. Now, this is 2 cubed to the power of 4. Now, something to the power of 4 is something times something times something times something. So 2 cubed to the power of 4 is 2 cubed times 2 cubed times 2 cubed times 2 cubed. Okay, well, I know when I multiply, I add the indices. So it's going to be 2 to the power of 3 plus 3 plus 3 plus 3. 2 to the power of 12. Or to put it another way, it's 2 to the power of 4 threes. 1, 3, 2, 3. 3 threes, 4 threes. 4 threes. Let's look at this one. Let's look at the algebraic one. X cubed to the power of 5. Well, it's something to the power of 5. X cubed to the power of 5. X cubed times x cubed times x cubed times x cubed times x cubed. Right. Well, I know that when I multiply, I add the indices. So I've got 3 plus 3 plus 3 plus 3 plus 3. X to the power of 15. Or to put it another way, I've got 5 threes. So it's x to the power of 15. Or I've got 5 threes. So if I wanted to work it out, perhaps a bit more efficiently, I could say, let's do 7 to the power of, let's do 7 to the power of 6 cubed. Well, I'm going to have 7 to the power of 3 sixes. 7 to the power of 18. Or algebraically, if I had a to the m raised to the power of n, I would have a to the power of n times m. So that's going to be a to the power of m n. All right, so those are the 3 things which you need to know about positive integer indices. And so here are some rules you might like to jot down. When we're multiplying, we add the indices. Here's an example for you, in case you find it useful to write down an example. And here is the rule algebraically. when we divide, we subtract the indices. Here's an example for you, and here's the rule algebraically. And when we raise an expression to a certain power, we multiply the 2 and the 4 together here. Or in this case, looking at the algebraic case, a to the power of m raised to the power of n is a to the power of m times n. And those are the 3 rules of indices with which you need to be pretty fluent. And we're going to do some questions now to practice those. Okay, so questions to practice. Here we are. There are 6 questions here. Why not pause the film and have a go at those? Jot down your answers as you're working, and then unpause the film, and I'll run through them quickly. Okay, let's have a look at these questions. Right, I'm going to look at 1, 3, and 5 first, because that's how my page here is laid out. So in number 1, I'm multiplying here. I'm simply going to add the indices 2 to the power of 10. Number 3, I'm dividing, so I'm going to have 2 to the power of 10 minus 4 to the power of 6. And in number 5, I've got 2 to the power of 3, 2 cubed, raised to the power of 4. So that is going to be 2 to the power of 3 times 4, 2 to the power of 12. Right, number 2, I'm adding the indices because I'm multiplying 4 to the power of 7. Number 4, well, 7 to the power of 13 over 7 to the power of 10 means 7 to the 13 divided by 7 to the 10. Subtract the powers, 7 cubed. And number 6, 6 squared raised to the power of 4 is 6 to the power of 2 times 4, 6 to the power of 8. That's those 6 questions done. All right, now here are some slightly harder ones. Pause the film, have a go at 7 to 14. Press play again when you're ready, and I'll run through them. Okay, question 7. Here we are. Right, question 7. A cubed times a to the power of 5. Sorry, a cubed times a squared. Add the indices, a to the power of 5. Number 9. E squared raised to the power of 3 is e to the power of 6. Number 11. Subtract those indices, c to the power of 5. Number 13. Right, well, I've got 2 times a cubed times 3 times a squared. Remember, you can multiply in any order, so really this is just 2 times 3 times a cubed times a squared. 2 times 3 is 6. A cubed times a squared, add the indices, a to the 5. So the answer is 6, a to the power of 5. But of course, you may have written that answer straight down, which is absolutely fine. Number 8, c to the power of 6 divided by c squared, c to the power of 4. Add these indices here, a squared times a cubed times a to the power of 4, a to the power of 9. 2 times 6 is 12. A to the power of 4 times a squared is a to the power of 6. 12 a to the power of 6. Now, number 14. Let's write this one down here. 2 times e to the power of 4 raised to the power of 2. Well, this section here, e to the power of 4 raised to the power of 2, is going to be e to the power of 8. So what I've got here is 2 e to the power of 8. Okay, right. Now, here are some more difficult questions. Last thing in this section here. Pause the film, have a go, and then I'll run through them. Okay. Let's have a look at 5, 6, 7, and 8. Number 5, relatively straightforward. Add the indices, a to the power of 12. Now, number 6. Right, I tend to write these as fractions. C to the power of 9 divided by 4c cubed. Now, that's a fraction. I can divide the top and bottom by what I like. I'm going to divide the top and bottom by 4 to start with, leaving me with 3c to the 9 over c cubed. And now I'm going to divide the top and bottom by c cubed, just to make it a bit clearer. I'll write divided by c cubed divided by 3c cubed. So that's going to give me, well, 3c to the 9 divided by c cubed, subtract those indices, 3c to the power 6. And of course, c cubed by c cubed divided by c cubed is 1. So my answer is simply 3c to the power of 6. Okay. Number 7. Well, that is 5 times e squared raised to the power 4. And that's e to the 8. So it's 5 times e to the power of 8, 5 e to the 8. And number 8. Right. 2g to the power 4 cubed. So that is going to be the 2 raised to the power of 3 and the g to the 4 raised to the power of 3. 2 times 2 times 2 is 8. G to the 4 raised to the power of 3 is g to the 4 times 3, 12. Let's look at the next 4 questions. Okay. Number 9. Right, well, this is 3 times 2j cubed raised to the power 4. Well, that's 2 raised to the power 4 times j cubed raised to the power 4. So that is going to be 2 to the power 4. 2, 4, 8, 16. 16 times 3, 48. J to the 12. Number 10. 3m times, and now I've got 2 cubed, 2 raised to the power 3, and m squared raised to the power 3. So that is going to be 3 times 2 cubed. 2 cubed is 8. 3 8s are 24. Times an m, times m to the power of, I'm thinking what this is, m to the power 6. So that's 24, m to the power 7. Right, running out of room here. Let's look at number 11 down here. 3a squared times by 3a squared to the power of 2. Well, that's 3 times a squared times 3 squared, which is 9, times a squared to the power of 2, which is a to the 4. So 3 9s are 27. A squared times a to the 4 is a to the 6. Number 12. Let's have a look at number 12. Now, the denominator here, sorry, the numerator, I beg your pardon, 2a to the 8 plus 2a to the 8 is 4a to the 8. And 4a to the 8 divided by 2a to the 8. Well, you might just say to yourself, I know that there are 2a to the 8s in 4a to the 8. Or you might instead decide to cancel this as if it was a fraction. You can divide top and bottom by 2, gives you 2a to the 8 over a to the 8. And now you can divide top and bottom by a to the 8, gives you 2 over 1, which is 2. So that's my number 12. Right, almost there. Number 13. That's right, number 13 down here. I've got 12b to the 8 divided by 6b to the 4. And then I'm going to add 6b to the 4. Right. Well, what is 12b to the 8 divided by 6b to the 4? You might just know the answer already, or you might want to work it out by dividing top and bottom of that fraction. I'm going to do it in the slower way. I'm going to divide top and bottom by 6, which is going to leave me with 2b to the 8 over b to the 4. Got to remember to copy down that plus 6b to the 4. And now I'm going to divide top and bottom by b to the 4. Leaves me with 2 b to the 8 divided by b to the 4. Subtract the indices. 2b to the 4 over 1 plus 6b to the 4. Well, 2b to the 4 over 1 is just 2b to the 4. So I've got 2b to the 4 plus 6b to the 4 gives me 8b to the power of 4. So that's number 13 done. And lastly, number 14. Let's look at the numerator, the top of this fraction here. b to the 4 plus 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 b to the 4. That is 6b to the 4 divided by b to the 4. Gives me an answer of 6. And that is the end of section 1. And that was all about dealing with positive integer indices and about applying these three rules here. Right, welcome to section 2, fractional indices. Now in this section, we're going to limit ourselves to looking at numerical expressions. So we're going to be looking at expressions like this one, 9 to the power of a half, or expressions like this one, 8 to the power of 2/3. Both of those have got fractional indices. The power is a fraction. Now the first thing that one needs to be able to deal with are powers such as a half or a third or a quarter and so on. So let's start off by looking at 9 to the power of a half. Now, you'll probably end up just learning that 9 to the power of a half is the square root of 9. And similarly, something to the power of a third, 8 to the power of a third, for example, is the cube root of 8. And similarly, something to the power of a quarter, 16 perhaps, to the power of a quarter, is the fourth root of 16. Let's just very quickly make sure you're okay with the idea that the square root of 9 is 3, because 3 3s are 9. Similarly, the cube root of 8 is 2, because 2 times 2 times 2 is 8. 2 cubed is 8. And the fourth root of 16 is also 2, because 2 times 2 times 2 times 2 is 16, or 2 to the power of 4 is 16. And let's look at an example of a fifth root, if I can do one off the top of my head. Perhaps the fifth root of 100,000. So 100,000 to the power of a fifth would be the fifth root of 100,000, which is 10, because 10 times 10 times 10 times 10 times 10 is 100,000. Okay, now you probably, as I say, will just learn that something to the half is a square root, something to the third is a cube root, something to the fourth is the fourth root, something to the fifth is the fifth root, and so on. But let's just take a moment to understand why that is. Let's take our 9 to the power of a half, for example. If I do 9 to the power of a half times 9 to the power of a half, as you know, you add the indices when you multiply, and a half plus a half is 1. So 9 to the power of a half plus times 9 to the power of a half is 9 to the power of 1. Look at that. 9 to the power of a half is the square root of 9 to the power of 1, because 9 to the power of a half times 9 to the power of a half, 9 to the power of a half squared is 9. Let's look at the 8 to the power of a third example. Let's imagine that we did 8 to the power of a third times 8 to the power of a third times 8 to the power of a third. Well, you know that when you multiply, you add the indices. So that's going to be 8 to the power of a third plus a third plus a third is 8 to the power of 1. Look at that. 8 to the power of 1 is 8 to the power of a third cubed. So the cube root of 8 is 8 to the power of a third. And that sort of logic works, of course, with all of them. So, first thing you need to know is what is written on the screen here, that something to the power of a half is a square root, something to the power of a third is a cube root, something to the power of 4 is a fourth root, and so on. Right, one more thing that you need to be aware of, and that is as follows. If 9 to the power of a half is 3, what about 9 to the power of 3 halves? Similarly, if 8 to the power of a third is 2, what about 8 to the power of 2/3? Or, if 16 to the power of a quarter is 2, what about 16 to the power of 3/4? Let's look at each of those examples. Now, 9 to the power of 3 halves. Well, we know what 9 to the power of a half is. And 9 to the power of 3 halves is 9 to the power of a half cubed, which is 3 cubed, which would be 27. Okay. 8 to the power of 2/3. Well, we'll take 8 to the power of 1/3 and we'll put it to the power of 2. Do you notice? 2/3, 2/3. And what would that equal, by the way? Well, 8 to the power of 1/3, the cube root of 8 is 2, and 2 squared is 4. All right. What about 16 to the power of 3/4? Well, we're going to take 16 to the power of a quarter and cube it. And do you notice? 3/4, 3/4. 6 to the power of a quarter, the fourth root of 16 is 2, and we're going to cube that. 2 times 2 times 2 is 8. So that is the second thing you need to be able to deal with. You need to be able to deal with numerical expressions where the power is a fraction, both when the fraction has a numerator of 1 and when the fraction does not have a numerator of 1. So here are your two rules, okay, in algebraic terms, but you'll probably just learn what to do. But here is x to the power of 1/mth being the mth root of x, and here is x to the power of n over m being the mth root raised to the power of n. Okay, and incidentally, that is equal to that, but I don't think one tends to use that terribly often. So those are the rules that you need to know, and now we're going to practice some questions. Okay, here are 8 questions. So pause the film, have a go at those questions, and then press play again, and I'll take you through them. All right, question 1. 25 to the power of a half, that's the square root of 25. 5. Question 2. 27 to the power of a third, that will be the cube root of 27. Something times something times something. Something times itself is 27. Answer 3. The fourth root of 16. Well, we had that in the examples. What to the power of 4 is 16? 2 to the power of 4 is 16. You could use a calculator, of course, for any of these. And part 4. The square root of 1/4. Well, that's going to be the square root of 1 over the square root of 4. 1 over 2. Okay, that's the first 4 questions. Let's have a look at questions 5, 6, 7, and 8. Okay, number 5. 9 to the power of 3 halves is going to be the square root of 9 cubed. And the square root of 9 is 3, so it's 3 cubed. 3 times 3 times 3, 27. Okay, the 8 to the power of 5/3 is going to be the cube root of 8 raised to the power of 5. The cube root of 8 is 2, so 2 to the power of 5. 2, 4, 8, 16, 32. Number 7, this fraction to the power of a half. Well, that's going to be the square root of the fraction, which is going to be the square root of 16 over the square root of 25, which is 4/5. And number 8, this fraction raised to the power of 3 halves. That's going to be 4 to the power of 3 halves over 9 to the power of 3 halves, which is the square root of 4 cubed over the square root of 9 cubed, which is 2 cubed over 3 cubed, which is 8 over 27. So that is questions 1 to 8 done there. Now, here are some harder examples. And I think that will be the end of this section once we've had a go at these. Press pause, press play when you're ready, and I'll take you through them. Okay. 1 to 3, let's have a look. 144 to the power of a half is the square root of 144, 12. Number 2, the square root of 900. Well, that is 30. And number 3, the cube root of 1/8 is going to be the cube root of 1. Try that again. It's going to be the cube root of 1 over the cube root of 8, which is 1/2. Okay, here we go. 4, 5, 6. Right. 1 over 32 to the power of a fifth. That's going to be 1 to the power of a fifth over 32 to the power of a fifth, which is the fifth root of 1 over the fifth root of 32, which is 1 over 2. 81 to the power of 3/4. Right. Well, that's going to be the fourth root of 81 cubed. So that is 3, because 3 is the fourth root of 81, to the power of 3. 3 cubed, 27. And number 6. This is going to be the cube root of minus 125 squared. Now the cube root of minus 125 is minus 5. And I need to square that. Minus 5 times minus 5 is 25. Remember, a minus times a minus is a plus. And that, I think, is the end of those more difficult questions. And that is the end of section 2, dealing with fractional indices. And in section 3, we will move on through the world of indices. We're going to look at fractional and negative indices in algebraic expressions in section 3. But for now, that's the end of section 2, and there are the rules that you need to be aware of. Right, welcome to section 3. In section 3, we're going to look at negative indices. We're going to restrict ourselves to numerical expressions with negative indices. In section 4, we'll be looking at algebraic expressions. So, in this section, we are looking at things such as 2 to the power of minus 2, or 8 to the power of minus 2/3. Now, both of those, of course, have got negative indices. 8 to the power of minus 2/3 has got a negative fractional power, a negative fractional index number. We're also going to be looking at fractions to negative indices, such as 2/3 to the power of minus 3, or 16 over 81 to the power of minus 3/4. So that's what we're looking at in this section. So 2 to the power of minus 2. Now the truth is that you're probably simply going to remember the rule for negative indices. 2 to the power of minus 2 is 1 over 2 to the power of 2. Let's give you another example. 8 to the power of minus 2/3 is 1 over 8 to the power of 2/3. You're probably getting the idea now. For instance, 10 to the power of minus 3 is 1 over 10 to the power of 3. Or 7 to the power of minus 6 is 1 over 7 to the 6. Okay, now let's have a look at these fractional ones here. 2/3 to the power of minus 3, that's going to be the reciprocal of the fraction, 3/2 instead of 2/3, to the power of 3. And 16/81 to the power of minus 3/4 is the reciprocal of 16/81, 81 over 16, to the power of 3/4. So to get rid of the negative power here, or to deal with the negative power here, we're simply, instead of 2, we've got 1 over. So 2 to the power of minus 2 is 1 over 2 squared. And to deal with the negative power when we've got fractions here, such as the 2/3, we've got the reciprocal of 2/3, and that's got rid of the negative power. Now, in fact, we're doing the same thing, because if I look at this 10 to the power of minus 3 example, well, 10 to the power of minus 3 is the same as 10 over 1 to the power of minus 3. And if I take the reciprocal of 10 over 1, I get 1 over 10 to the power of 3, which is just 1 over 10 cubed. So if you think about this whole number as being a fraction over 1, you're still taking the reciprocal of that fraction. Similarly, 7 to the power of minus 6 is 7 over 1 to the power of minus 6, so it becomes 1 over 7 to the power of 6. So what we do to deal with the negative power is we take the reciprocal. But the honest truth is that you're probably simply going to remember that x to the power of minus n is 1 over x to the power n. Or similarly, x to the power of y, say to the power of minus 1, is y over x, or x to the power of y, say to the power of minus n, is the reciprocal y over x to the power of n. Let's have a look at the rules here. So what we've got here is we've got n to the power of minus 1 is 1 over n. That's what we've just been looking at. And also, x over y to the power of minus n is equal to y over x to the power of n. A couple of other rules here. X to the power of minus 1 is 1 over x. Well, that's sort of common sense because x to the power of minus 1 would be 1 over x to the power of 1, which is, of course, the same as 1 over x. And all this is saying is that you can't have 1 divided by 0, so x can't be 0. And this last rule here is probably just one you're going to learn. Anything to the power of 0 is 1. So, for instance, 7 to the power of 0 is 1. Anything to the power of 0 is 1. Right, we're going to use those rules now and put them into practice. So, here are 20 questions. Right, so I suggest that you pause the film, have a go at all of these or some of these as you like, press play when you're ready, and I'll work through these 20 questions and take you through them. So over to you, pause the film and have a go. Okay, question 1. 3 to the power of minus 2, well, that's going to be 1 over 3 squared, a ninth. 2 to the power of minus 3 is 1 over 2 cubed, an eighth. 4 to the power of minus 1, 1 over 4 to the 1, a quarter. 3 to the power of minus 2 to the power of minus 1. Okay, so that's going to be 1 over 3 to the power of minus 2, which is going to be 3 over 1 squared, which is going to be 9. 3 to the power of minus 2 divided by 3 to the power of minus 1. Well, let me write that here. You know that when you divide, you simply subtract the powers. So this is going to be 3 to the power of minus 2 minus minus 1. 3 to the power of minus 1, or 1/3. Or you could have done that in another way. You could have said, okay, this first one is 1 over 3 squared divided by 1 over 3, which is a ninth divided by 1/3. So keep, change, flip. 3 over 1 there, of course. So top times top, bottom times bottom is 1/3. Okay, let's have a look at the next few questions. Number 6, well, 5 to the 0, well, anything to the power of 0 is 1. Number 7, a half to the power of minus 1 is simply the reciprocal of that fraction to the power of 1. 2 over 1, 2. 3 quarters to the power of minus 1 is simply the reciprocal of 3 quarters, 4/3. 1/3 to the power of minus 4 is the reciprocal of 1/3 to the power of 4, which is 3 to the power of 4 over 1 to the power of 4, which is 81 over 1, 81. And number 10, 2/3 to the power of minus 3 is the reciprocal of 2/3 cubed. So that's 3 cubed, 27, over 2 cubed, 8. Number 11 to 15 coming up. Here we are. Right. 5/3 to the power of minus 2 is 3/5, the reciprocal of 5/3 squared, 9 25ths. 81 to the power of minus 1/3, well, that is 1 over sorry, is 8 to the power of minus a third. It's 1 over 8 to the power of a third. Well, that's 1 over the cube root of 8, isn't it? So it's a half. 25 to the power of minus a half. Well, that's 1 over 25 to the power of a half. 25 to the power of a half is the square root of 25. So it's 1 over 5. 16 to the power of minus 3 quarters is 1 over 16 to the power of 3 quarters, which is 1 over the fourth root of 16 cubed, which is 1 over 2 cubed, which is an eighth. Minus 1 to the power of minus 3 halves. Well, there's a trick here, but let's ignore the trick for a moment. That's going to be 1 over 1 to the power of 3 halves, which is 1 over the square root of 1 cubed, which is 1 over 1 cubed, which is 1 over 1, which is 1. And the trick is that 1 to the power of anything is 1. Right, let's move our way down and look at the last few questions. Okay, a quarter to the power of minus a half is the reciprocal of a quarter to the power of a half, which is the square root of 4, 2, over the square root of 1, which is 1. So 2 over 1, 2. 1/8 to the power of minus 2/3 is 8 over 1 to the power of 2/3, which is the cube root of 8 squared over the cube root of 1 squared, which is just 1. So that gives me 2 squared, 4. 18. 4/9 to the power of minus a half is 9 quarters to the power of a half, which is the square root of the top over the square root of the bottom, 3 over 2. Number 19, let's look at the numerator. I've got 4 to the power of minus 3 times 4 to the power of minus 1. Add those, 4 to the power of minus 4. But on the denominator, I've got 4 to the power of minus 4. Well, 4 to the power of minus 4 divided by 4 to the power of minus 4 is something divided by itself, 1. Number 20, now there's a trick here. Right, let's have a look. We've got 27 to the power of minus a third. So that's going to be 1 over 27 to the power of a third times the square root of 9 cubed. So that is going to be 1 over the cube root of 27 is 3 times 3 cubed, which is a third of 27, which is 9. Okay, right, let's see what's coming next. Now, here are 16 more difficult questions. Once we've done these more difficult questions, then we'll go on to look at some equations. But first of all, have a go at these 16, or whichever ones you choose of these 16. Press pause while you do that, press play again, and we'll go through these 16. Okay, number 1. 5 to the power of minus 2 is 1 over 5 squared, 1/25. Number 2. 4 to the power of minus 3 is 1 over 4 cubed, 1 over 64. 12 to the power of minus 1 is 1 over 12. Number 4. A quarter to the power of minus 1 is the reciprocal of a quarter to the power of 1. It's simply 4. Number 5 coming up. Here we go. 2/7 to the power of minus 2 is 7 halves squared. So it's 49 over 4. 4/5 to the power of minus 3 is 5 quarters cubed. So 5 cubed, 125, over 4 cubed, 64. 1 2/3 to the power of minus 2. Well, before we flip the fraction, let's turn it into top heavy. So it's 5/3 to the power of minus 2. Now I can find the reciprocal of that, 3/5 squared, 9 over 25. Number 8, 64 to the power of minus a half. Well, that's going to be 1 over 64 to the power of a half. So it's the square root of the top over the square root of the bottom, 1/8. Okay, number 9. 16 to the power of minus a quarter. It's going to be 1 over 16 to the power of a quarter. So that is 1 over, because the fourth root of 1 is 1, 1 over the fourth root of 16, which is 1/2. 8 to the power of minus 5/3. It's going to be 1 over 8 to the power of 5/3, which is 1 to the power of 5/3. That's just going to be 1 over 8 to the power of 5/3. Right. So that's 1 over the cube root of 8 to the power of 5, which is 1 over 2 to the power of 5. 2, 4, 8, 16, 32. Number 11. Well, that's 1 to the power of something. So the answer is going to be 1. Number 12. 1 over 81 to the power of minus a half is 81 over 1 to the power of a half. It's just the square root of 81. 9. 1 over 125 to the power of minus 2/3 is going to be 125 over 1 to the power of 2/3, which is the cube root of 125 squared, 5 squared, 25 over 1. 27 over 8 to the power of minus 4/3 is 8 over 27 to the power of 4/3. The cube root of 8, which is 2 to the power of 4, over the cube root of 27, which is 3 to the power of 4. 2 times 2 times 2 times 2, 16 over 81. 162 over 32 to the power of minus 3/4. Wait a moment. Can you see how you can cancel this fraction before you do anything else? 81 over 16 to the power of minus 3/4. So that is 16 over 81 to the power of 3/4. So that's the fourth root of 16, 2 cubed, over the fourth root of 81, 3 cubed. So that's 8 over 27. And number 16, 2 divided by 32 to the minus a fifth is 1 over 32 to the power of a fifth. So that's the fifth root of 1 over the fifth root of 32. So that's 2 divided by 1 over 2. How many halves in 2? 4. And that's number 16 done. Right. Now, the last thing that you need to be able to do here is solve equations that look like these ones. So if you think you know what you're doing, press pause and have a go. And if you don't, watch me do the first couple and then press pause and try the rest yourself. Now, I've got some easy equations here, and then in a moment, some trickier equations. And then that is this section finished. So let's have a look at these apparently easier equations. Right, number 21, we've got 1 over 7, and that equals 7 to the power of what? Well, 1 over 7 is 7 to the power of minus 1. So 7 to the power of minus 1 equals 7 to the power of x, meaning that x equals minus 1. Let's look at number 22. Here's number 22, this one. We've got a quarter to the power of x equals 4. Well, a quarter to the power of minus 1 equals 4, doesn't it? So x is going to equal minus 1. Let's have a look at number 23. Okay. So number 23, I've got 3 halves to the power of x equals 2/3. Well, it must be 3 halves to the power of minus 1, mustn't it? So x will equal minus 1. Let's have a look at number 24. 2/3 to the power of x has to equal 9/4. Well, what's happened to this 2/3 here? it's been swapped over, hasn't it? I've got the reciprocal of 2/3, 3/2, and then that's been squared. So x must be -2, because if it were to the power of -2, we'd find the reciprocal and square it, which would give us 9/4. And number 25 now. 16 over 25 to the power of x equals 5 over 4. Well, this 5 is linked to the 25, isn't it? And the 4 is linked to the 16. So we're definitely using the reciprocal of the fraction. So we've got a negative power. And then we've square rooted, haven't we? So x must be -1/2, because 16 over 25 to the power of -1/2 would give you 5 over 4. Okay, so those are those easier equations there, solving for x. Let's have a look at these more difficult ones. Right, there are 5 questions here. You might want to pause and have a go, and then watch me, or watch me do a couple, and then pause and have a go at the rest yourself. Okay, number 21. We've got 4/5 to the power of something is 25/16. Well, clearly the 5 is linked to the 25 and the 4 to the 16. So we're obviously dealing with a negative power here. And actually the 5's been squared and the 4's been squared. So in number 21, 4/5 to the power of what? Well, it must be to the power of -2. That would equal 25 over 16. So the answer to the equation is that x equals -2. Right, let's have a look at number 22. Right, the 49 is linked to the 7 and the 64 to the 8. So we're dealing with a negative power because we need the reciprocal of that fraction. And in this case, we're square rooting. So 49 to the power of 6 over 64 must have been put to the power of -1/2 to get 8 over 7. So the answer to this equation is x equals -1/2. Let's look at number 23 now. Okay, number 23. Right, here it is. Now, for number 23, 24, and 25, we're going to have to use a technique we haven't had to use so far, and that is to put things into the same base. Let me show you what I mean. We're looking at number 23 here. So, in number 23, we have the cube root of 5 to the power 4, and that equals 25 to the power x. Now, we can put both of these into what we'd call base 5, express both of these as 5 to the power of. The left-hand side here is 5 to the power of 4/3. Now the right-hand side, 25 is 5 times 5. So that's 5 times 5 to the power x. So 5 to the power of 4/3 is 5 times x times 5 to the power of x, which is 5 to the power of 2x. So now I've expressed both left and right side in base 5, I can see that that power must be equal to that power. So 4/3 must be equal to 2x, in which case x is equal to half of 4/3, 2/3. Let's have a look at number 24. Now, number 24, I have got 1 over 8 to the power of 12 equals 16 to the power of x. Now, the base I'm going to put both of these into is base 2, because I can write the 1/8 as 1 over 2 cubed to the power of 12, and I can write the 16 as 2 to the power of 2, 4, 8, 2 to the power of 4 to the power of x. So my left-hand side is 2 to the power of -3 to the power of 12, and on the right-hand side I've got 2 to the power of 4 to the power of x. Now, using my rules of indices, 2 to the power of -3 to the power of 12 is 2 to the power of -3 times 12, -36. And the right-hand side is 2 to the power of 4 times x, 4x. So now I've got both of these as 2 to the power of something. I know that my two powers must be equal. So minus 36 must equal 4x. So x must equal minus 9. And now let's have a look at number 25. Let's go over here. I have got 8 to the power of minus 8 thirds. And that equals a quarter to the power of x. Well, let's write both of these into base 2. So I've got 8 is 2 cubed. So I've got 2 cubed to the power of minus 8 thirds. And that equals 1 over 2 squared to the power of x. Well, 2 cubed to the power of minus 8 thirds is 2 to the power of 3 times minus 8 thirds, minus 8. And this is 1 over, sorry, no it's not. This is 1 over 2 squared, which is 2 to the power of minus 2. And I'm going to put that to the power of x. So 2 to the power of minus 8 on the left-hand side equals 2 to the power of minus 2x. So minus 8 equals minus 2x. So x equals 4. And that is the end of question 25. And that is the end of that section. Section 4, right, fractional and negative indices algebraically. We're going to be dealing with algebraic expressions now with fractional and negative indices. And there's no new maths here. All the maths we've covered in sections 1, 2 and 3. We're just now applying these same rules to algebraic expressions and I think a little to numerical expressions too. Let's have a look. Right, here are 16 questions for you to dive into. What I would do is pause the film, have a go at these questions, and then press play again, and I'll take you through each of them. Right, here we go. Okay. Number 1. Right, we've got a to the power of minus 2 times a squared divided by a to the power of minus 2. Now remember that when you multiply, you add the powers. So a to the power of minus 2 times a squared is going to be a to the power of minus 2 plus 2. And then when I divide by a to the power of minus 2, I'm going to subtract that negative power. So that is going to become a squared. Minus 2 plus 2 is 0. Minus minus 2 is plus 2. In the same way, I'm going to have b to the power of 4 plus minus 3 minus minus 2, which is b to the power of 1 plus 2, b cubed. Right, this is 2 times c squared to the power of minus 2, which is 2 times c to the power of 2 times minus 2, minus 4. And if I'm going to simplify that properly, then you shouldn't really have negative indices in your answer, so that should be written as 2 over c to the power of 4. Number 4. This one is going to be 2 squared times c to the power of minus 1 squared, which is 4 times c to the power of minus 2. And so I should write that really as 4 over c squared, so that I don't have a negative power in my answer. Right, 3 times 4 is 12. A to the power of minus 2 times a is a to the power of minus 1. So 12 over a. And number 6, 4 twos are 8. B squared times b to the power of minus 3. 2 plus minus 3 is minus 1. 8 times b to the power of minus 1. 8 over b. Moving on. Number 7. Add the indices, a to the power of 1 or just a. Number 8. Subtract the indices, b to the power of 0. Anything to the power of 0 is 1. Number 9. That's going to be c to the power of minus 2 times a half, which is going to be c to the power of minus 1, which is 1 over c. Number 10. Right, d to the power of a third to the power of minus 3, it's going to be 1 over d to the third to the power of 3. So that's 1 to the power of 3, which is 1, over d to the power of a third to the power of 3. And that's the cube root of d cubed. So I simply have D. Number 11. Let's write this one as a fraction. Minus 3a all cubed divided by 3a to the power of minus 3. Okay. Well, minus 3a cubed is going to be minus 3 cubed minus 27 times a cubed. And that's going to be divided by 3a to the power of minus 3. Divide top and bottom by 3, minus 9a cubed over a to the power of minus 3. Now you can think about this in a few different ways. I'm going to multiply top and bottom by a to the power of 3. Why am I doing that? Because that, a to the power of 3, will mean that my denominator, a to the power of minus 3 times a to the power of 3, is simply 1. And on the top, I will have minus 9a to the 6. So my answer is simply minus 9a to the power of 6. And lastly, number 12, a to the power of a half times a to the power of minus 2.5. Well, I'm going to add the indices. So I'm going to have a half plus minus 2.5, which is a to the power of minus 2, which is 1 over a squared. And that's all the questions up to number 12. All right. Number 13. Right, let's have a look at this one. They do have a habit of looking really complicated, don't they? So we're going to have, let's just write down the question, c to the power of minus 2 1/3 divided by c to the power of minus 1/3. So that is c to the power of, let's make that top heavy, minus 7/3 divided by c to the power of minus 1/3. Remember, if you're dividing, you subtract the indices. So this is simply going to be c to the power of minus 7/3 minus minus 1/3. Okay, well that is c to the power of minus 7/3 plus 1/3. All right, that's c to the power of minus 6/3, which is c to the power of minus 2, which is 1 over c squared. Okay, so that is number 13. Let's look at number 14. Right, do that here. I've got e to the power of minus 1/2 to the power of minus 2. Well, that is simply e to the power of minus 1/2 times minus 2, which is e to the power of minus times minus is a plus, and 1/2 times 2 is 1. E to the power of 1, e. Right, number 15. Right, find k if x to the power of k equals that expression there. Let's write that down. So we've got x to the power of k equaling the cube root of x divided by 1 over x squared. Right, so let's mess around with the right hand side here. So that's x to the power of 1/3 divided by x to the power of minus 2. Okay, well remember, if you divide you subtract the powers. So 1/3 minus minus 2 is 1/3 plus 2. So that's x to the power of 2 1/3. So I've got x to the power of k equals x to the power of 2 1/3. So therefore k must equal 2 1/3. Right, number 16. I've got again to find k. Right, so I've got x to the power of k minus 1 equals x squared to the power of minus 2 divided by x cubed. Well, that means that my right-hand side here is equal to, now the numerator there is x to the power of minus 4, 2 times minus 2, and that's divided by x cubed. So that is x to the power of minus 4 minus 3 minus 7. So x to the power of k minus 1 is x to the power of minus 7. So k minus 1 equals minus 7. So k equals minus 6. And that is those questions done. Now, here are some harder examples. And then after these examples, we have finished all the 4 sections of theory, and then I will run through some IGCSE questions in the last section of this film. So press pause on this, have a go at these questions, and then I will run through them. Okay, number 17. On the left-hand side, I've got a to the power of x, b to the power of y, to the power of a sixth. So that's going to give me a to the power of x times a sixth times b to the power of y times a sixth, y over 6. And I know that equals a to the power of a half times b to the power of minus a third. So x over 6 must equal a half. And in the same way, y over 6 must equal minus a third. And that's how I'm going to work out x and how I'm going to work out y. X over 6 equals a half. So x equals 3, multiplying both sides by 6. And y over 6 equals minus a third. So y equals minus 2, multiplying both sides by 6. Let's have a look at number 18. Right. On the left-hand side here, what have I got? Well, I've got a to the power of 4/5, b to the power of minus 3/5. And I know that equals a to the x, b to the y. So x must equal 4/5, and y must equal minus 3/5. So x equals 4/5, and y equals minus 3/5. Okay. Number 19. Now, let's have a look at A. I've got 27 to the power of minus a third times by 9 to the power of 3/2. Well, 27 to the power of minus a third is 1 over the cube root of 27, 1 over 3, times by the square root of 9 is 3 cubed. So that is a third of 27, which is 9. Part B. I've got 4 25ths to the power of minus 3 over 2 times 8 27ths to the power of a third. So that is, let's get rid of that negative power. So the reciprocal, the fraction, the reciprocal of the fraction to the power of 3 over 2 times the cube root of 8, 2 over the cube root of 27. So that left-hand fraction there, it's the square root of 25 cubed. So that's 5 cubed, 125. Over the square root of 4, 2 cubed, 8, multiplied by 2 over 3, which gives me 250 over 24, which can be cancelled down, I'm sure, if I just stick that into a calculator using the fraction function. 250 over 24 equals 125 over 12. I think I could manage that without the calculator. But never mind. Right. Let's have a look at part C. Part C. 81 over 16 to the power of 3/4 times by 9 over 25 to the power of minus 3/2. Okay. So this first fraction is going to be the 4th root of 81, which is 3, cubed, 27. Over the 4th root of 16, which is 2, cubed, 8. Times. I've got a negative power on the second fraction, so I'll simply remove that negative power and use the reciprocal of the fraction. So I've got 27 over 8 times the square root of 25 is 5, cubed is 125, over the square root of 9 is 3, cubed is 27. So multiplying that out, I simply get 125 over 8. Right, moving on to question 20. Now in question 20, well, certainly looking at the first couple, I think we're going to be dealing with writing things in the same route here. Let's have a look. 20a. 16 equals 2 to the power of what? 2 to the power of 4 is 16, so n must equal 4. Part B, the cube root of 27 is the same as 27 to the power of what? Well, 27 to the power of a third. And part C, 1 over 100 is 10 to the power of what? Answer 10 to the power of minus 2. So that is A, B, and C done. Right. Let's look at D. D says the square root of 9 over 4. Well, the square root of 9 over... the square root of 4 over 9, which is 4 over 9 to the power of a half, isn't it? Equals 9 over 4 to the power n. Well, I haven't quite got the left-hand side to 9 over 4 yet. That's switching it over, so I'd need to have minus a half there. Look at that. So n is minus a half. Let's look at E. I've got 3 to the power of a half to the power of 7 equals 3 to the power of n. Well, my left-hand side is going to be 3 to the power of a half times 7, 3.5, is 3 to the power of n, so n must be 3.5. Okay, and now I simply need to do part F. Let's have a look at that. I've got the 4th root of 8 to the power of 7 equals 8 to the power of something. Right, I'm dealing with base 8 here, so I'm not going to change this 8 into 2's. So I've got the 4th root of 8 is 8 to the quarter to the power of 7 equals 8 to the n. So the left-hand side is 8 to the power of a quarter times 7, 7 over 4 equals 8 to the n. So n must equal 7 quarters. And that is question 20 done. And that's the end of this section. And that's the end of all the theory that you need to answer IGCSE questions now involving indices. So in the next section, I will go through a whole load of IGCSE questions for you. Mr. Right here, and welcome to section 5, IGCSE questions on indices. Now, I've taken all of these from higher papers, and towards the end of these questions, I think there are 25 questions in all, the last 7, 8, certainly 4 or 5 questions are very definitely level 8 or 9. So the questions get more difficult as we go on, but crikey, at the end, the questions are really quite tough. If you'd like to download the questions, you can do so by clicking the link in the description, and then you can have a go at the questions before me and then watch the film, or you can work on the questions whilst you're watching the film and work alongside me. Absolutely up to you, but let's now get on with the maths. Okay, question 1. Now, throughout these questions, I am unashamedly going to use the rules of indices. So now that we understand the rules of indices, and if you're not sure of any of them, I suggest you watch the earlier parts of this film, then we can simply get on and use them. So in this case, I'm dividing. I'm going to subtract the powers, e to the power of 4. Part B, I've got y squared, which I'm raising to the power of 8. So that's going to be y to the power of 2 times 8, y to the power of 16. Part C, I'm raising this expression here to the power of 3. So I'm going to have 3 cubed, which is 27. X squared raised to the power of 3. 2 times 3 is 6. So x to the power of 6. Y to the power of 5 cubed is y to the power of 5 times 3, 15. And part D, I need to write this fraction in the form y to the power of b. So essentially, I need to write this fraction as y to the power of something and see what that something is going to be. Let's have a look. The top of the fraction is the 4th root of y, so that's y to the power of a quarter, and that's over y. Now, that means y to the power of a quarter divided by y. When I divide, I subtract the powers, and this is y to the power of 1 here. So my answer is going to be y to the power of a quarter divided by y to the power of 1 is y to the power of 1 quarter minus 1. So y to the power of minus 3 quarters. And that is question 1 complete. Question 2. Right, now quite often you get equations that look like this one. I've got w to the power of 5 times w to the power of n divided by w cubed. And I know that gives me w10, and I'm being asked to find the value of n. Right, two ways of thinking about this. Lots of people like to get rid of that w cubed on the bottom there, so they like to multiply both sides by w cubed. That gives me w to the 5 times w to the n equals, and on the right-hand side, I'm going to have w to the 10 multiplied by w cubed, w to the power of 13. And now I simply need to have a look at the left and have a think about what does this n have to be. So that w to the power of 5 multiplied by w to the power of n gives me w to the power of 13. And the answer is it must be w to the power of 8. So n equals 8. A second way of doing this question is to simply say to yourself, well, on the left-hand side, I'm going to have w to the power of 5 plus n minus 3. And that equals w to the power of 10. So I've got an equation 2 plus n equals 10, and hence n equals 8. Okay, part B. Simplify a to the power of 0. Well, a to the power of 0, anything to the power of 0, is equal to 1. And part C here, I've got a fraction, 3xy cubed divided by 6x squared y. What can I divide the top and bottom by? Well, first of all, by 3. Leaves me with that. Secondly, by x, leaves me with y cubed and 2xy. And thirdly, by y, to leave me with y squared over 2x. Now, I've done that in several stages. You could have done it all at once. Up to you. And that's the end of question 2. Question 3. Simplify 2 divided by y to the 0. Well, that is simply 2 over 1, because anything to the power of 0 is 1. So my answer is just 2. Part B. Right, I've got 16 a to the power of 4, and I'm putting that to the power of 3 quarters. So what I'm going to have is I'm going to have 16 to the power of 3 quarters multiplied by a to the 4 to the power of 3 quarters. Right, well, 16 to the power of 3 quarters, that's the 4th root of 16, which is 2, cubed, which gives me 8. Or you could, in your calculator, have simply typed in 16 to the power of 3 quarters and seen what you got. Now, a to the power of 4 raised to the power of 3 quarters is simply going to be 4 times 3 quarters. It's going to be a to the power of 4 times 3 quarters. So that's a cubed. And that is question 3 done. It's not actually question 3 done, because here's the last part, and here is another of these equations. I'm going to multiply both sides by y to the power of 6, gives me y to the 5 multiplied by y to the n equals y to the power of 19. So n is 19 minus 5, n is 14. And now I'll move on to question 4. Right, I'm multiplying, so I'm going to add the indices. I'm going to raise 4 to the power of 3 and raise y squared to the power of 3. I'm going to subtract the indices. I'm going to raise 2 to the power of 4, 2, 4, 8, 16, g cubed to the power of 4 to give me g to the power of 3 times 4, and k to the 5 to the power of 4 to give me k to the power of 5 times 4, 20. Part E, another equation. Right, in this case, I'm going to have y to the power of 5 multiplied by y to the power of n equals y to the power of 19. I've multiplied both sides by y to the power of 7. So now I know that n is going to be 19 minus 5. N is 14. Okay, let's crack on. Question 5. 8 to the power of, well, anything to the power of 0 is 1, so it's just 8 times 1, 8. Okay, I've got x to the power of 6 divided by x to the power of minus 5, and the answer is x to the power of p. Find the value of p. Well, I would subtract the indices, so I would do 6 minus 5. So p equals 11. Simplify fully. Right, I'm going to raise the 2 to the power of 3, k squared to the power of 3, multiplying those indices, m to the 4 to the power of 3, multiplying those indices. That is question 5 done. Question 6. Right, the trick with these questions is to do one thing at a time. Don't mess it up. I'm just going to start by copying down the question so that I can see it a bit more clearly. Here it is. Right, the first thing I'm going to do is I'm going to get rid of that negative on the power. So I'm going to use the reciprocal of the fraction. And now that is the power of 3/4. All right, so this is going to be the top to the power of 3/4 over the bottom to the power of 3/4. So the top to the power of 3/4, that's y to the 20 raised to the power of 3/4. So that's going to be y to the 15, and to work that out, all I did was 20 times 3/4, as I'm raising it to the power of 3/4. 16 to the power of 3/4, you could use your calculator for that, or you'd know the 4th root is 2, and 2 cubed is 8. And w to the 8 to the power of 3/4, well, that would be w to the power of 8 times 3/4, w to the power of 6. So that is question 6a done. And let's look at question 6b now. I'll write it out so I can see it more clearly. 2x to the power of 5 over 8xy squared, and that's the power of negative 2. So let's flip that over, and now I will just have to the power of 2. So all I've got to do is square the top and square the bottom. Okay, well, 8 8s is 64. X squared is x squared, and y squared is y to the 4. Over 2 squared is 4, x to the power of 5 squared is x to the power of 10. Now be careful. Do you see how it says simplify fully? Because if you look at that, you can now divide the top and bottom. So I can simplify this fraction. I'm going to divide the top and bottom by 4x squared. Okay, which is going to give me 16y to the 4 over x to the 10. No, x to the 8. 10 minus this 2. So that is the answer. Frankly, I'm feeling a bit embarrassed now, because if I had looked at this more carefully, I could have seen that I could have cancelled it originally. I could have divided the top and bottom by 2x before I did anything else, and that would have given me the right answer as well. Right, that is question 6 done. So let's move on to question 7. Right, I've got 64 p to the power of 9 q to the power of 12, and I'm putting that to the power of 2/3. So I'm going to need to put 64 to the power of 2/3. Well, the cube root of 64 is 4, so square that gives me 16. And you could have, on your calculator, simply have written in 64 to the power of 2/3 and seen what you got. P to the 9 to the power of 2/3. Well, that's going to be p to the power of 9 times 2/3, p to the power of 6. And q to the power of 12 raised to the power of 2/3 would be q to the power of 12 times 2/3, q to the power of 8. And that's question 7 done. Question 8. Right, part A. Well, this is just something to the power of 0. So it simply equals 1. Right, 3 to the minus 14 multiplied by 3 to the power of 8. Well, I'm going to add the indices, of course. So that's going to give me 3 to the power of minus 6. So m must equal minus 6. Part C. Express that expression in the form m to the something times k to the something over something. Right, let's have a look. So we've got m to the 6, k to the 10 over 25. And all of that is the power 3 over 2. Right, so the top to the power of 3 over 2. Well, I can simply multiply my indices by the power to which they're being raised. So that's going to be m to the power of, well, 6 times 3 over 2 is 9. K to the power of 10 times 3 over 2 is 15. And now 25 to the power of 3 over 2. Well, I'm going to square root 25 and then cube it. So it's going to be 5 cubed, 125. And that is part C sorted. Right, question 9. Simplify fully. I've got 32 a to the power of 15 all to the power of 3/5. So I've got to raise 32 to the power of 3/5. Well, obviously you could use your calculator to work out 32 to the power of 3/5. And I've got a raised to the power of a to the 15 raised to the power of 3/5. I'm going to do 15 multiplied by 3/5, which is a to the 9. So that works out to be 8 a to the 9. Part B. Aha, something to the power of minus 3. So the first thing I'm going to do is write that as 10x over 1 to the power of 3. So that's going to be 10x to the power of 3, 10 to the power of 3, x to the power of 3, over 1 to the power of 3, which is 1. So it simply equals 1000 x to the power of 3, 1000x cubed. Question 10. Simplify here. Well, I'll simply subtract the indices. K to the n times k to the power of 4 equals k to the power of 12. Well, what would that n have to be there? Answer would have to be k to the 8, wouldn't it? So n would have to equal 8. And part C, I'm going to raise 3 to the power of 2. X to the 6 squared is x to the 12. And x to the 8 raised to the power of 2 is x to the 16. Question 11. Right, 2 raised to the power of 3 is 8. C to the power of 12, d to the power of 21. Part B, find the value of y times y to the 0. Well, anything to the 0 is 1, so that is simply 5 times 1, which is 5. Question 12. Write down the value of m, given that 3 to the 4 times 3 to the 5 equals 3 to the m. Well, 3 to the 4 times 3 to the 5 is 3 to the 9, so m must equal 9. Part B, write down the value of n, given that 5 to the 3 raised to the power of 7 is 5, I think that must be 5 to the power of n there, but let's answer it in both ways if we can. So that would be 5 to the power of 21, wouldn't it? So I reckon that the question means to say 5 to the power of n, in which case n would be 21. Now, thinking about it, it might be that the question isn't misprinted and they mean to say 5 to the power of 3 times 5 to the power of 7 equals 5 to the power of what? Sorry, I'll say that again. It might be that the question's supposed to say 5 cubed raised to the power of 7 equals 5 multiplied by what? So perhaps it's not a misprint. Maybe they mean that. Let's have a think about it in case that is what they mean. This is 5 to the power of 21, and that equals 5 times what? Well, 5 to the power of 21 is 5 times 5 to the power of 20. So n would be 5 to the power of 20. Now, thinking aloud, I suspect that it's not a misprint, and I suspect that the blue version is the correct one, although that's different to any other question that we've seen. Part C. Right, 7 to the 8 times 7 to the 2 over 7 to the p. And I need to find the value of p, given that 7 to the 8 times 7 to the 2 over 7 to the value power of p. I think this is another base print. I think that's supposed to equal something. So who knows what? So let's move on from question C. Right, question 13. Write down the value of something to the 0. Answer, anything to the 0 is 1. Given that 2 to the power of minus 3 times 2 to the power of 9 equals 2 to the power of n, find the value of n. Well, 2 to the power of minus 3 multiplied by 2 to the power of 9 equals 2 to the power of 6. So n equals 6. Given that, change colour here, 7 to the power of 206 times 7 to the power of m over 7 to the power of 214 equals 7 to the power of minus 3, find the value of m. Well, let's multiply both sides by 7 to the power of 214. That's going to leave 7 to the power of 206 times 7 to the power of m. And on the right-hand side, I'm going to have 7 to the minus 3 multiplied by 7 to the power of 214. Add the indices, gives me 7 to the power of 211. Right, so what will this m have to be to make this equation hold water? Answer, it will have to be 7 to the 5, so m would have to be 5. Okay, question 14. Right, solve 2 to the power of something equals 32. Well, 2 to the power of what is 32? Let's see, 2 squared is 4, 8, 16, 32. So 2 to the power of 5 is 32. So my minus 4x must equal 5. So in which case, x must equal minus 5 over 4. And that is question 14 sorted. Question 15. Right, I'm going to add the indices, gives me a to the power of 11. I'm going to subtract the indices, w to the power of 12. I'm going to raise each of these to the power of 2. 8 8s is 64. X to the 5 times x to the 5, x to the 10, and y cubed times y cubed, y to the 6. Question 16. Find an expression for x in terms of k and n. Right. Now I'm going to write all of these into base 2, and you'll find that some of these harder questions require you to quite naturally write expressions in different bases. Now on the bottom here I've got 4 to the n. So that's going to be 2 to the power of k over now 4 to the n. 4 to the n is 2 squared, right? So that's 2 squared. Done it again. So that's 2 squared to the power of n, because 4 is 2 squared. And that equals 2 to the x. Right, let's continue simplifying here. So I've got 2 to the power of k divided by, now 2 squared risen to the power of n. You multiply those, don't you? So that's 2 to the power of 2n equals 2 to the power of x. Okay, now this left-hand side is 2 to the power of k divided by 2 to the power of 2n. And of course you subtract the indices, so that's going to be 2 to the power of k minus 2n. So on the left-hand side I've got 2 to the power of k minus 2n, and I know that equals 2 to the power of x. Well, in that case, k minus 2n must equal x. So k minus 2n must equal x. So x equals k minus 2n. And the question says, find an expression for x in terms of k and n, and I have done that. Question 16 is done. Here comes question 17. Another one where I have to put things in the same base. Let's have a look. So I have got 2 to the power of 7 multiplied by 4 to the power of 5, and that equals 4 to the power of x. Let's put everything in base 2. 2 to the power of 7 already in base 2. That 4 is 2 squared. So what I've got here is 2 squared raised to the power of 5. The right-hand side, this 4 is 2 squared. So I've got 2 squared raised to the power of x. So that means that 2 to the 7 multiplied by 2 to the, now what's this? 2 times 5, 2 to the power of 10, is equal to 2 to the power of, what's this, 2 times x, 2 to the power of 2x. So on the left-hand side, I've got 2 to the power of 17, and that equals 2 to the power of 2x. So how? And in that case, 17 must equal 2x. So 17 equals 2x, 2x equals 17, x equals 8.5. Part B, simplify this fully. So I've got 125, p to the 6, y to the 24. And I'm going to raise that to the power of 2/3. Now 125 to the power of 2/3. Now you could do that on a calculator, but I know the cube root of 125 is 5, so square that gives me 25. P to the power of 6, raise the power of 2/3, well, that's just going to be p to the power of 6 times 2/3, p to the power of 4. And in the same way, y to the power of 24 divided by y to the power of 2/3 will be y to the power of 16. Question 18. Right, write down the value of y to the 0, 1. Simplify this fully. Let's have a look. We've got 9 t to the 4 w to the 9 over 18 t to the 6 w to the 10. And that's all to the power of minus 2. Now this time, I see it's a simplify fully, and I see I can do some cancelling before I do anything else. I could divide the top by 9 t to the power of 4 w to the power of 9, and I can divide the bottom by the same. So I'm going to divide top and bottom by 9 t to the 4 w to the 9. T to the 4 w to the 9. I'm going to simplify the fraction within the bracket. So I'm still going to have a fraction to the power of minus 2. But what's my fraction going to be now? Well, the top divided by 9t to the 4w to the 9 is 1. And the bottom divided by 9t to the 4w to the 9 is 2t squared w. Right, now get rid of that minus power. Let's flip the fraction. And now I've just got that. That's a 1 there, sorry. So I've flipped the fraction, and now I've simply got that to the power of 2. So that's going to be 4 t to the 4 w squared over 1 squared is 1. So the answer is simply 4 t to the 4 w squared. Okay, let's move on to question 19. Right, I'm raising this expression to the power of 4. So 2 to the power of 4, 2, 4, 8, 16. X cubed to the power of 4 is x to the 12. Y to the 5 to the power of 4 is y to the 20. And that's question 19 done. Question 20, write down the value of m plus 2 to the power of 0. Well, anything to the power of 0 is simply 1. So the answer is that m plus 2 to the power of 0 equals 1. Simplify this expression. I'm raising everything there to the power of 3. So 3 cubed is 27. A squared cubed is a to the 6. And b to the 4 cubed is b to the 12. Question 21. Right, 3 to the half multiplied by 3 to the 2/5 is equal to 3 to the m. Well, let's work out what 3 to the half multiplied by 3 to the power of 2/5 is. All I've actually got to do is add those indices. So all I've got to do is a half plus 2/5, which is going to give me 9/10. So the left-hand side is 3 to the power of 9/10. So 3 to the power of 9/10 equals 3 to the power of m. What's m? Well, clearly m is 9/10. And part B, well, here I'm dividing. So I've got 5 to the power of minus 10 divided by 5 to the power of minus 4, and that equals 5 to the power of n. Well, if I was doing 5 to the power of minus 10 divided by 5 to the power of minus 4, I would subtract those indices. So I'd have minus 10 minus minus 4, minus 10 plus 4, minus 6. So that's 5 to the power of minus 6 equals 5 to the power of n. So n equals minus 6. And that is question 21 done. Question 22, right, we're definitely in the realm of grade 8, grade 9 here. What have we got? Well, we've got the square root of 2 divided by 8 cubed over 16 to the power of 3 over 2 equals 2 to the power of n, and we're being asked to work out the value of n. So what we're being asked to do is we're being asked to take the left-hand side here, and we're being asked to write that as 2 to the power of something. So what we're going to do is take the left-hand side and write it all in base 2. So I've got 2 to the power of a half divided by 8 is 2 cubed. So 8 cubed is 2 cubed cubed. 16 is 2 to the power of 4. So I've got 2 to the power of 4 to the power of 3 over 2. Right, let's continue. That is 2 to the power of a half divided by, now remember, your rules of indices. The top there is equal to 2 to the power of 9, and that's divided by 2 to the power of, again, rules of indices, 4 times 3 halves is 2 to the power of 6. So what have we got? We've got 2 to the power of a half divided by, now what does this fraction equal here? Well, it's 2 to the power of 9 divided by 2 to the power of 6, subtract the indices, 2 to the power of 3. So what I've got here is 2 to the power of a half divided by 2 cubed, subtract the indices, 2 to the power of minus 2 and a half. So n is equal to minus 2 and a half. Right, let's look at part B. I've got 8 over 2 to the power of 7. And that equals 2 to the n, and I'm being asked to find the value of n. So again, I'm being asked to write the left-hand side as 2 to the power of something. So I'm going to write the left-hand side in base 2. 2 cubed over 2 to the power of 7 equals 2 to the power of n. Well, 2 cubed over 2 to the power of 7 is 2 to the power of minus 4. So 2 to the power of minus 4 equals n. So n must equal minus 4. And part C. Right, I've got 13 to the power of minus 6 raised to the power of 4 times 13 to the power of 5. So that is 13 to the power of minus 6 times 4 is minus 24 times 13 to the power of 5. So that is 13 to the power of minus 19, adding those indices. And that equals 13 to the power of k. So clearly k equals minus 19. All right, question 23. Okay, let's have a look at this. I've got the cube root of 1 over x, which is being raised to the power of 4. So I have got 1 over x to the power of a third, which is being raised to the power of 4. So that is x to the power of minus a third being raised to the power of 4. So that is, remember your rules of indices, x to the power of minus 4 thirds, and that equals x to the power of m. So m equals minus 4 thirds. Okay, part B. Now remember, do one thing at a time. Let's first of all write down what I've got here. I've got 27 a to the power of 12 over t to the power of 15, all to the power of minus 2 thirds. First of all, let's flip the fraction and get rid of that negative power. Okay, so that is going to be the power of 2 thirds. Okay, so I've got to do t to the power of 15 raised to the power of 2 thirds. So that's going to be t to the power of 15 times 2 thirds is 10. Over, now 27 to the power of 2 thirds, you could do that on a calculator, or you could know that the cube root of 27 is 3, and when you square that you get 9. And a to the 12 to the power of 2 thirds is a to the power of 12 times 2 thirds, which is a to the power of 8. So that is that question done. Question 24. Express x in terms of n. Right, let's see what we've got here. We have got 18 multiplied by the square root of 27 to the power of 4n plus 6 over 6 times 9 to the power of 2n plus 8, and that equals 3 to the power of x. Okay, well, let's simplify the left-hand side, shall we? So on the top, now 18, that's 2 9s. So I'm going to write that as 2 times 3 squared, times square root of 27. Well, 27 is 3 cubed. So what I've got here is I've got the square root of 3 cubed, and that's being raised to the power of 4n plus 6. Okay, meanwhile, the bottom here, 2 times 3 times 9 is 3 squared, so I've got 3 squared, being raised to the power of 2n plus 8. Okay. Right, what shall I do next? Oh, well, I can divide top and bottom by 2. So that's easily done. Okay. I really dislike crossing out, but never mind. I've divided top and bottom by 2. I'm going to leave the 3's as they are. I mean, I know I could do some further simplification, but I'm not going to. So on the top, I've got 3 squared. 3 squared times. Now, square root of 3 cubed is 3 cubed to the power of a half. And you'd multiply those, so it's 3 to the power of 3 halves. So I've got 3 to the power of 3 over 2, which is being raised to the power of 4n plus 6. And on the denominator there, I've got 3 times, now 3 squared raised to the power of 2n plus 8. Remember your rules. It's going to be 3 to the power of 2 times 2n plus 8. So that's going to be 3 to the power of 4n plus 16. Okay, right, let's continue with this simplifying. So I have got on the top, still 3 squared, times. I've got 3 to the power of 3 over 2, which I'm raising to the power of 4n plus 6. So I'm going to multiply 3 over 2 by 4n plus 6. So that gives me 3 to the power of 6n plus 9. And that is all over 3 to the times 3 to the power of 4n plus 16. Okay. Right, well, I can simplify the top here just by adding these indices, can't I? I can do 3 to the power of something times 3 to the power of something else. Add those indices, I'm going to get 3 to the power of 6n plus 11. And on the bottom here, in the same way, I'm going to have, that's a 3 to the power 1. So then I'm going to add the indices. So I'm going to have 3 to the power of 4n plus 17. Okay, now let's just go back to the beginning of the question. All of this, I'm trying to get it in the form of simply 3 to the power of something. Now, I've got 3 to the power of 6n plus 11 divided by 3 to the power of 4n plus 17. So I'm going to subtract those powers. But of course, I'm going to be very careful. So I've got 6n plus 11 minus, put that in a bracket so I don't mess up the signs. So that's going to be 3 to the power of, let's write that 11 a bit more legibly. I'm going to have 6n minus 4n, so that's 2n. Then I've got plus 11 minus 17 plus 18. So that is what the left-hand side boils down to, and that equals 3 to the power of x. So that tells me that x must equal 2n plus 18. Now let's just go back to the question. It says express x in terms of n, and that is what I've done there. So that is question 24 sorted. Mr. Right here, and well done if you have made it through all of those IGCSE questions. Some of the harder ones towards the end were definitely grade 8, grade 9, no question. If you found the film useful, please hit like. If you've got any questions, please leave them in the comments. And if you are preparing for your IGCSE Maths, then do follow the channel, do subscribe. There is lots there that is useful to you. Thanks for watching. Good luck with your maths.